Today's talk is called Command Performance, the Why and Whether of Small-Scale Optimizations. It has its roots, this talk, in this familiar quotation. Have people seen this before? Okay. In fact, I've kind of, in a way, stacked the deck against myself by choosing like the most hackneyed, cliched possible phrase in all of computerdom and try to say something original or interesting about it. One thing I'll mention is, I'm taking it a little bit out of, well, probably a lot out of context, but I have to tell you that I have, looked at a lot of people commenting on this and so forth. I still don't know who said it. I mean, really, you have to just sort of choose sides, and everybody, there's sort of cases for both of them. I have not been able to make head or tails of that. So we're just going to do an and or here and assume that it probably doesn't matter all that much for this purpose who said it. I'm not here to sort of prove the rightness or wrongness of this. I think there's actually a lot of discussion of that already. What I want to do is just really kind of a series of sort of riffs on thinking about this, taking it apart a little bit, allowing it to take me in some directions that I hope you'll find interesting. So this is kind of the seed quotation, but again, I'm not here to specifically to sort of prove it right or wrong. In fact, one of the things I find most interesting about this phrase, the phrase itself, is it never seems to be exactly right or wrong. This is something that's kind of intrigued me, that in a lot of discussions, whatever, on mailing lists and forums and so forth, somebody will do something in code and somebody else will say, that's premature optimization, you shouldn't do it. And then someone else will say, well, not all optimization is premature, maybe it's non-premature optimization. And the discussion will kind of go on like that for a while and then sort of peter out. And there's this strange thing where it feels like a very important concept, very important quote, and yet it sort of gets caught in this, could Michelle or somebody, yeah, thank you. Yeah, the cocktail party's going full strength out there. And yet the quote gets caught in this sort of twilight region where it's not, nobody says, yeah, you're right, I shouldn't have done that, it's premature optimization, and nobody says, premature optimization is great. So the quote just seems to be used a lot, but always in a way that's sort of a little bit of a misfit. So as I say, I'm not trying to sort of prove or disprove it itself. I'm just intrigued by some of its usage and some of the thoughts that might grow out of it. This talk is organized loosely, well, not too loosely, organized in what I think of as 4 chapters or segments. And they will be punctuated with little code demos also. Of these segments, the prematurity in software development, optimization versus melioration, I think I may have talked about the idea of meliorism a little bit last year, but I want to expand on that. Optimization as a reflex, and some comments on small-scale optimizations in Ruby. In a sense, the 4th of these was kind of my focus or starting point in putting together this set of ideas. I've been in, and I'll get to, obviously it chronologically comes last, but as you'll see, some of the code samples pertain to this too. I've always been intrigued by the idea that maybe, just maybe, we could identify certain idioms in a given language that just were faster, given more than one way to do something. That there might just be a faster way to do it. There was some beeping and stuff going on back here, but that stopped anyway. And Ruby is kind of my home base language, so examples and so forth will be in Ruby, but should be fairly accessible, I think, to those of you who've done or maybe even not done some Ruby. All right, that brings me to my first code demo. Now, okay, you're supposed to be able to hit escape and get out of this. Come on, open office. Well, that's interesting. Aha, okay, I think I know what I did. All right. Sorry, let me resize this a little bit. Not sure quite what it's doing. Okay. All right. Yes, edit. Wow, sorry. Come on. Okay. Read only we'll have to do for now. All right. One of the examples in Ruby of an idiom where there might just be a way to optimize without making too big a song and dance out of it is the difference between matching a regular expression with the tilde, the equal tilde operator, and matching it with the match method. Now, these two things return different things. If you use the equal tilde operator, it will return, if there is no match, it will return nil. And if there is a match, it will return the offset into the string where the match occurs. That means since numbers are, including 0, are true in Ruby, that means that you can use this in an if statement. You can say if A, B, C, D, E, tilde, a regular expression of E, and it will come back as essentially false if there isn't a match and positive if there is. The match method also returns nil if there's no match. If there is a match, it returns a match data object, which is a somewhat heavier weight item than just a number. And this is actually a case where if you go ahead and run this, oh, I'm sorry, let me just, what I'm doing here is actually a benchmark. If those of you who've seen that do Ruby have probably seen this in the past. I'm basically saying with running this 500,000 times, I'm basically just, this is a very simple kind of, non-subtle benchmark, but I'm just saying let's run each of these and show a report of what we get. So the Ruby we're using at the moment is Ruby Enterprise Edition 187. Hello, stop. And I'm just going to run this file and see what we get. All right, the first two lines are the rehearsal, which is designed to kind of cut out system noise, so you can ignore that essentially, although it's almost the same as the final run, where the match, sure enough, doing it with the match object takes longer. So this is, sort of phase one of looking at this problem about can we optimize on a small scale without falling afoul of the premature optimization issue. Yeah, here you can, and interestingly, let's try JRuby on this. Now I was going to say JRuby rehearsals are typically rather different from the actual run. You can see here the rehearsal, something was going on there other than just the Ruby. But what's interesting is here they get a lot closer. And as I'll comment on a little bit later, one of the things that in sort of trying to look at Ruby idioms that you can run faster just by choosing one over the other, I've hit some interpreter related issues, so we'll come back to that. All right. The first chapter, that was the prologue, right? The first chapter or segment I want to talk about is prematurity and software development. The whole idea of premature optimization suggests that there's a kind of maturity cycle in software development. And I find this interesting because I'm not sure, in a lot of cases, I'm not sure there actually is. Let me digress for a moment into media studies, a field that I used to be in full time, and the subject of soap operas. Now, a soap opera, as Robert Allen, among other scholars, has pointed out, a soap opera is all middle, right? the beginnings, yes, every soap opera had a first episode. Most of the long-running ones, if the first episode was on the radio in the 20s or something, it's gone, right? There are probably sort of origin myths surrounding it. A soap opera has no obvious end. They do end. I think a number of the long-running ones have been ending recently. So it is possible to end a soap opera, but traditionally, a soap opera is all middle. Whenever you turn it on, you're in the middle of something. It's not the beginning, it's not the end. I find that software kind of obeys a similar principle in certain respects. Sorry. A lot of software projects, the beginnings, maybe not literally lost in the mists of time, but often there is almost a kind of creation myth ethos surrounding the beginnings of projects, especially if the personnel have changed and it's like, oh, look at this, oh, that must have been so-and-so back in whenever who, wrote that bunch of code. So the beginnings of a lot of projects are kind of lost-ish. And what's interesting moreover is that there's often no end in sight. In other words, a lot of us operate in a lot of projects on a kind of iterative model where you're not really, in a sense, finishing the software. You're just working on the middle. It's sort of all middle. Every time you work on the software, you're working on something that's in progress. And yes, you have releases and you have iterations and so forth. But essentially, you're not really saying, oh, tomorrow we're going to be done with this. Now, I'm generalizing a lot. Of course, there are projects that end. And one thing I find interesting is that when I think of a project that has ended, just a program that got written and it's done and here it is, I think of TeX, Donald Knuth's typesetting system. I don't know if that's just the Donald Knuth meme sort of asserting itself. But, in that case, he actually did finish the program, and now, as you probably know, he accepts bug reports but not feature requests, and this has been true for 27 years, whatever it is. The version if you don't know, the version numbers of TeX, every time there's a bug report, which I don't think there has been for a while, but the version number of TeX is converging on pi. So it's 3.14, whatever, and he just adds a digit from pi whenever there's something new. So that's a real kind of position statement about this is written, it's done, take it or leave it. And in that case, it's not all middle. And what that suggests to me is that, and sort of the point of this all middle concept is, how is it meaningful to talk about premature optimization in projects that are in this kind of perpetual adolescence? In other words, at what point do you say, well, we've reached maturity, there's nothing left but the optimizations? Because in a lot of cases, we're not really tending in that direction. We're kind of living in this middle world, so to speak, where everything is iterating, but it's also kind of open-ended. I thought I would regale you with one other concept from literary theory, the French theorist Gerard Genette, who talks about, in case of fiction, essentially, talks about, in analyzing novels and film also, the iterative versus the singulative. The idea is that if you're writing a novel, whatever, a lot of the prose that you write is going to be iterative in the sense that it's about things that happen regularly in the lives of the characters. So, like every other day, I got up and had breakfast and did whatever. And then the singulative are those events that are singularities, that only happen at a certain point in the narrative. So you could say, I got up and had breakfast, and suddenly a brick was thrown through the window, or something like that. So you have the iterative, the sort of pattern of life, pattern of narrative, and then the singulative, which kind of erupts into life and makes, in most cases, kind of the point of the story. And it seems to me that software, again, it's just kind of an intriguing analogy, that in a lot of software development, we're doing, we even use the word iteration. So we're doing things in an iterative way. And in that sense, kind of, one iteration much resembles another if you sort of, look at it from enough of a distance. But there are also singularities. A given iteration might involve introducing a new feature, or something like that, or be a sort of major release. So again, I think software development is, it is an art form, and it's, I think, just kind of intriguing to look at it in a little bit in those connections. And again, the starting point being to think about what does it mean for it to be mature if it's kind of constantly evolving and constantly becoming something. So how do you know when software is mature, and how do you know in an iterative process when you're done? And I mean, again, I'm oversimplifying a little bit. It's not that you can't ever have a conversation about optimization and whether it's premature or not. There seems to me to be, and this again goes to the question of why does the quote, the famous quote, always feel a little bit right and a little bit wrong? Because I think there is this sort of tension between the iterative and the mature, the complete. Second code demo. These are just little sort of intermission things between chapters. But let's see, what have we got here? We look, whoops, that's not what we want. That's what we want, okay. I'm on a different screen, that's why. All right, so this is a little just entr'acte or whatever. We looked at the match one. Another one that often comes up in talking about optimization in Ruby, the small scale optimization, is yield versus block call. Now, what's going on here is I'm providing a code block, I'm calling a method, and providing a code block, and that's actually happening down here. I have two methods, one called yielder, which just yields control back to the block, and one called caller, which captures the block using this ampersand syntax. It captures the block in a variable and sort of manually or explicitly calls it. And this is one where, again, you get sort of discussions like, oh, you're using call, don't use call, it's faster to just yield. So, partly there's the question of whether it really matters in a given case, but also just of interest perhaps to see what happens. So again, the rehearsal and then the real, and we find that caller actually is significantly slower. And I think, let's see, yeah, I mean, it's all a little bit different, but I mean, neither of them is that slow in JRuby, at least, this very simplified example. Which Ruby am I in? Oh, yeah. Just out of curiosity, whoops, I don't mean Ruby. I've got Ruby version manager going here, so we can actually look at a few. Yeah, that, again, there's sort of less at stake here in the sense that neither of them is as slow as it was in the other version of Ruby, but still just kind of an interesting sidebar. All right, second segment or chapter in the thinking about some of these concepts, optimization versus melioration. And melioration is a word, and there's also amelioration with an A. I'm using this one because I'm interested in looking at it from the point of view of the word meliorism, which people think was possibly coined by George Eliot, who used this term in some of her correspondence anyway, if not in her novels, I'm not sure. The idea of meliorism, from melior, right, Latin for better, I believe, is that it's neither optimism nor pessimism. In other words, you're not thinking that everything's great or can be great. You're not thinking that everything's terrible. It's a kind of philosophical position that things can be made better. Things can be better and be made better. And I find this interesting because, I don't know if there's such thing as premature melioration. I mean, in other words, if you can make something better and not necessarily make it perfect, but improve it, there's probably not much argument against doing that. And in fact, it does, not necessarily in the area of performance or optimization, but certainly Bob Martin and others have talked about leave code better than how you found it. as a kind of precept of writing clean code or as a kind of coding philosophy. So I think there's room for all of us to be meliorists and to kind of embrace that position. And like I say, you don't really have to worry about premature meliorization. I don't think there is such a thing. I think making things better is always a good idea. At least I would like to think so. That was kind of a quick chapter. All right, let's see what else we've got here. Well, one that I was kind of curious about is inject. This one's a little more code, but basically what I'm doing here is I'm running the benchmark on the inject method. So here, what I'm doing is I'm injecting into a hash, and I'm basically, it will loop through the, I've got an array. This is actually an array of 1 through 10. That's just a sort of cute Ruby way to create an array of 1 through 10 by sort of exploding a range object into an array. So I'm injecting it with the accumulator being a hash, and each time through, I set, this is just kind of, dummy code. I set the hash for that value to 1, and then I return the hash. The reason I return the hash is so that it will be positioned here as the first argument next time through the loop. I've always disliked this. I always have disliked sort of explicitly returning the accumulator instead of implicitly. And so I kind of wanted to prove, or I was kind of hoping that it would turn out to be a lot faster to do it using a temporary variable. And I know that's very kind of out of fashion and unfunctional probably, but I wanted to do it anyway. So here I just basically set the accumulator or the value in the hash explicitly, and then I don't have to, since it's not an inject, I don't have to worry about returning or sort of evaluating back to the accumulator the way I do here. So what do we get if we run this? This is a little slower, just I left the same number of runs. So it's not dramatic. It carries the point a little bit. It's not dramatic. So we can't necessarily argue that you should always do it that way, but still, it's kind of possibly useful little metric. All right, a third kind of outcropping of this or thought that I've had about it is the idea of optimization as a reflex. And what I mean by that, here's an interesting quote from someone named Joe Duffy. I don't know him, I don't think, but this was on someone else's blog post about the Knuth quote. Given the choice between two ways of writing a line of code, both with similar readability, writability, and maintainability properties, and yet interestingly different performance profiles, don't be a bozo. Choose the performant approach. This is a little bit what I've been poking into with these Ruby examples. If you can, just by typing the word yield instead of the word call, if you can, in most cases, get a performance gain from it, I guess my question, in a sense, is then why not do it? In other words, if you can do, if you can sort of adopt a number of idioms that, where playing the percentages anyway, they'll probably be a little bit faster. Is there any reason not to do that? And this is, again, one of the things that when people talk about premature optimization, I sometimes wonder, what is the harm if I say, well, I'm using yield because it's a little bit faster. It's like as soon as I say it, maybe if I just use yield or use a temporary variable instead of inject or whatever, nobody will really notice it. Nobody will really remark on it. But once it's tagged as premature optimization, it gains a kind of stigma almost. Why are you doing that? Well, it looks at least equally good, and it, I think, probably runs a little faster. You'll immediately get pounced on, and somebody will say, that's premature optimization, don't think about that. And my question is, why not? And, yeah, it is maybe premature in a sense, but why not train your fingers and your brain to come up with a little bit more performant code. I mean, what's the harm? It takes about 20 seconds to, to see that probably in most cases this is going to be a tiny bit faster. And so why is it, of all the things we talk about, so many coding habits, so many ways of thinking about code and sort of instilling good practices, part of the problem for me with the optimization quote is that it's kind of discredited and I don't mean the quote itself, but really how it's applied. It sort of discredited the idea that it might be worth sort of teaching yourself or training yourself to use even just slightly more performant idioms. Now, I'm not, just so you know, I'm not sort of trying to second guess the idea that if you want to know how your code performs, you have to measure it. I mean, there's no question of that. This is not about sort of, learning 3 or 4 things you can do in Ruby and then everything's, performant. But I just wonder why there's, of all the coding things we do, why there's this kind of stigma against training yourself to use particular idioms. This is just a kind of semi-humorous example, but optimization by attrition. I mean, the kind of reductio ad absurdum, so to speak, of this argument is, if you write a method that's going to return 10, you can write it in a variety of ways. Sorry, is that a question?
I really had a comment back on the last.
Oh yeah, sure.
But I think it actually goes to what you're trying to get at here. There's an interesting notion here. If they are similar readability, writability, maintainability, in other words, all things being equal, do you want the optimal one? Yes. And I think there's a fine line that's probably worth noting between when it is equal up versus introducing complexity in the anticipation of optimization. And I think it's that line that I think people seem to have trouble with.
Right. Yeah, no, I think that's true, though I see just in discussions and sort of people reacting to each other's code, the idea of, oh, don't do that, you're optimizing prematurely, almost where if you didn't even say, I'm, given these 2 choices, I'm going to go with the one that I have some reason to think is faster. But yeah, then people will kind of,
Yeah, and this is almost like an abuse of the original quote.
A little bit, yeah.
Intentionally make it stupid.
What's that?
Intentionally making it stupid seems like an abuse of the original quote.
I think, yeah, I mean, that's the thing. Again, I think the original quote has been, dragged around and overused and misinterpreted a lot and so on. And yeah, definitely, yes.
So going on that point,
yeah.
The original quote and dealing with optimization and performance, is there any basis? Because I understand some of the basis for why the quote would be out there. You don't want to optimize something that's not a bottleneck. Is there any history of that? Like understanding what constraints are, what bottlenecks are, and not driving 70 miles an hour towards the crash rather than 20 miles an hour? You know what I'm saying?
I'm not sure.
If I'm running a system, ecosystem, and I'm in the ops side of it, and I'm watching the CPU spike for some reason.
Right.
And it's because somebody prematurely optimized a piece of code that wasn't a bottleneck, and I actually say I have a disk constraint that's weighing me down. Does any of that come into play, or is just code weenies just out there saying hey, this is the way to do stuff?
I think it does. I mean, I think, you mean just in terms of the use of the quotation, or, I think it's been.
I just haven't seen any background on real performance optimization from that quote. I just see people being really stickler about, hey, don't do anything to improve the code before we actually.
Right.
It's more.
Oh, I think if I had a dime for every time I've seen it, I'd be retired.
Right.
I mean, the number of times it's less about one-liners, the more where you really see the problem. I think that's, we're getting caught in semantics a little bit, is, I think the original intent of avoiding premature optimization is the number of times you'll see someone, and what they'll do is they'll decide up front that this is going to be the bottleneck, and they'll write some complex workaround there to optimize for it. Introducing caching where you may not need it, or changing the storage pattern. And it does 2 things. One is it very often creates its own bottleneck. But more often, when the real bottleneck comes out, it's in the way. It's obscuring the code. And that's what I actually thought was so wonderful about that quote, is for similar readability, maintainability. In other words, all things being equal, please be fast. But please don't don't guess to be fast when things are not equal. And on the whole, things are usually not equal.
By temporary variables over and down, right?
Yeah, and don't go there just because you think it might be. That's worth measuring because you're adding numbers. But you know what? That's one line. It's when it's a 30% expansion of code. That's when you're paying. That's when you pay a price that makes it harder to optimize in the end.
And also, I think, the idea of premature optimization as the root of all evil, again, not to belabor the wording too much, but I think as opposed to optimization being evil, which is almost sometimes how it gets interpreted or sort of glossed on. So yes, optimization by attrition. I mean, this is a kind of whimsical example, but I can't help thinking the person who writes the thing on the left is obviously, it's going to run at least a little bit slower than the thing on the right. Now, if somebody changes it to the thing on the right, and I say, wait a minute, you're optimizing, right? I mean, again, there comes a point where you just say, well, this is what rolls off my fingers, right? Because I don't want to be sort of suboptimal if I can help it. And I guess my point is, if I allow my brain and fingers to know how to do this, how different is that? Or, at that point, why can't I also train my fingers to use yield instead of call? Why is that premature optimization and this is just sort of common sense? And that brings us to code demo number 4. This one actually was a contrast between, in terms of basically concatenating strings. There's a few ways you can do this in Ruby. One of the first one there, the ABC arrow arrow DEF, the idea of that one is you're appending the second string onto the first string in place. So it's actually just mutating the first string. The second one, where you use the plus sign, is creating a third string from the two that are on either side of the plus sign. And I was curious, this is actually, this particular pairing of techniques or idioms usually comes up in connection, not necessarily with optimization, but in connection with memory usage. Essentially, if you add a lot of strings with a plus sign, you're allocating memory for extra strings. So it's, usually when people kind of lock horns about this or talk about it, that's what they're focusing on. But I became curious about the performance. And so let's see what we get here. I think, I don't think there's any dramatic difference, just for fun. Yeah, the plus sign a tiny bit, but it's not really a major thing. Yes?
I think the big thing with that particular issue is when you're building a long string with multiple concatenations.
Right, yeah.
And you'll see a very dramatic performance difference in that case.
Because every time you do it, you're creating a new string and then a new string and a new string. Yeah. Right, I've kind of reduced it to almost the minimum possible. Is that a performance? I mean, do you think it is, as well as just being a memory hit? I mean, is it because you're creating so many intermediate objects?
It's a matter of the way the string grows.
Uh-huh.
Just reallocating and reallocating and reallocating.
Yeah.
Create lots of intermediate objects, which is a memory issue.
Yeah.
Performance issue.
Yeah.
It'd be interesting if you change your.
Well, all right. Let's see what we. Okay, tell me what to compare them. I'd have to,
Create a variable outside the loop and keep concatenating to the same string.
so wait, what am I doing now? I'm going to be, actually we probably want, do we want two strings? Yeah. Now to do this, I have to say
T equals.
T plot, right? Okay. Now, maybe not 500 or 5 million times. Should we reduce that a little? Just see what happens. Well, that one went very quickly. Yeah. Yeah, well. Maybe I'll back out of that one. Just in case. All right, thank you, Jim. That's a good point, that one of them sort of grows more gracefully than the other, right? Okay. Whoops, not tools. So actually my fourth segment or chapter is really sort of the cumulative effect of those code demos, and the question of whether there are certain idioms that you should just, for a given language, just kind of get in your fingers. And I have to say, one thing is that in preparing this talk, I actually underwent, well, a little bit of a change on this. I mean, I used to, well, it's not a huge change, but basically, as you can surmise, my feeling is, yeah, why not learn to do the append thing instead of the plus sign if it actually is different and can be demonstrated on average to be faster. Why not, unless there's some reason not to, or if it is less readable or less maintainable, that's different. But given a sort of equal choice, why not just sort of train yourself to know that one of them is a little bit faster than the other, or a lot faster if you've got a lot of data. But what's interesting is I kind of hit the thing of different interpreters. So like with the match one, I think it was like JRuby, there wasn't really a significant difference. And this is kind of relatively new on the Ruby horizon, not brand new, but for a long time we had essentially one Ruby interpreter, and so you could teach yourself based on the behavior of that interpreter. And now that there's different Ruby interpreters, it's made a little more complex. It's a little harder to just say, in an absolute way, use yield whenever you can, because otherwise you're wasting, maybe it's not a big deal that you're wasting a few cycles, but yield actually runs faster. The landscape is a little more complex, I think, now that there's different interpreters. And again, I'm not trying to second guess the very sound rule that if you want to know how your code performs, you want to actually measure it and see what's going on. So I've kind of reached the end. We still have a little while. I've reached pretty much the end of what I wanted to say, but I'm interested in questions, discussions. Joe?
Well, actually, I was really just wondering which. I saw that you were primarily using REE and JRuby. What was the third Ruby?
The third Ruby I used was 192. I'm not sure what.
It seems to me that when you ran a few of them, 192 anything faster than REE, which was interesting.
Which one? I don't remember which one that was.
That's the first one. But I wonder if I just...
Was faster than REE?
Yeah.
No, I don't. I think they're comparable. Actually, REE seems a little faster on the match.
There was one that was faster.
Really? Yeah. Again, it pays to measure.
The blocks and the yielding.
Oh, the yield? All right. Let me just try that. This is REE. And this is 192. Yeah, right. Actually, I do remember that. Yeah. I don't know if that's something just in 187, that sort of hasn't been optimized out in REE. But yeah, 192, they're a little bit closer and faster. Yes, Ariel.
So what's interesting is that yesterday Jim presented about when you're writing unit tests, and it's sort of like there's all these dependencies in your code, and it's like something that makes us feel better to write unit tests that run really fast. It's it's sort of like I'm constantly looking at the unit test to run really fast. But then sometimes I feel this tension where it's like I want to make the unit test run really fast, but then when I put all the stuff together in a very large system, and I have a lot of information that I have to deal with, now I find myself like re-optimizing and making the unit test slower so I can do stuff like, you know, offload work from one machine to another. What do you recommend to sort of balance that out when you're working? You know, trying to make your test suite fast versus trying to make your production code fast versus trying to make your system at large fast.
Yeah, I don't know that I have a just sort of off-the-cuff recommendation, but it's certainly an important area. I did not hear Jim's talk, unfortunately, but yeah, I mean, I think we'll leave it a slightly rhetorical question if that's all right, but yeah, it's certainly interesting. Yes.
Yes, I really like the premise of this talk, and thank you for it. Just a comment, I'm noticing with, especially Ruby on Rails, there are places that you know you're going to get into trouble because you know that you're embedding in plus another situation. Where an optimization, just a tiny one-line optimization can make a huge difference, like an active record include or something like that. So, you know, great talk, great message.
Thanks. Thank you. Yes.
Yeah, I just had a comment about the original, the original quote, the basis of the talk, the new quote, so it's attributed. I sort of view that quote as referring to the activity of optimization for its own sake versus, the activity of writing code. So the difference between writing code that by default is somewhat faster based on the slight, between things versus, okay, I think I need to make this system or this thing faster, so I'm going to spend some time working on optimizing it. But I think the quote is talking about not doing that, without knowing, without being sure and having a measure as to what it means.
Right. I think the original is also, as I understand it, about not only premature, well, I mean, premature optimization is the phrase that's used, but it also seems like sort of low percentage optimization, things that are not tight loops or, code that's run once where nobody's really going to notice. I mean, unless it's some really situation where you have to shave literally nanoseconds off something, not optimizing things that are not really a problem to start with. Yes.
So you talked about how a lot of software projects seem to be all middle.
Yes.
And they don't really hit that maturity stage where you say, well, now it's time to go back and optimize.
Yeah.
How do we know necessarily when we hit that point? Like, as you build a system, unoptimal code creeps in. Performance slows down as you're building newer features. So how do you make that choice of, okay, I need to stop putting new things in and go clean up, the old stuff? How do I know when it's no longer premature if everything is middle?
That's kind of my question. I'm not sure if there's a kind of formula for it. I think it's, in some cases, fairly obvious. I mean, I guess one thing would just be not to condemn all optimization as premature. I mean, to kind of look at it as just a sort of different paradigm, that we're not waiting until there's nothing left to do but go back and optimize. I guess one thing would be not to let the quote make you afraid to optimize, or the quote or its sort of message. Yes, Jim.
My personal metric for premature optimization is that if you haven't measured it, it's premature.
Right. Yes, I think that's definitely right. Yes.
One of the things what I'm trying to get our guys and where I work at is before they develop something, set targets.
Yeah.
And then you measure those targets along the line.
Right.
I see optimization sort of at two levels. Like at one point, you're looking to hunt down your tool set to see what is the API and how can I use that API the most efficiently. There's some operations that can't be done efficiently by the API, like the plus sign, maybe the angle bracket can be. And you have a tendency when you're looking down the call, looking to optimize down there. And then writing code that you know what the use case is going to be,
Mhm.
it's actually easier to know when optimization makes sense or not. Every time I write something and I'm like, oh, I don't have to optimize that, somebody is going to have some case where they've got a million database tables, and I'm going to hear about it, you know? So
Right.
I'm always looking for that ON squared behavior that I've got in my code, and I know somebody's going to complain about that.
Uh-huh.
So I'm often looking to see how it's going to scale. And if I'm using a loop to do a lookup for every entry and I do a sequential scan, I know I'm going to die at some point.
Right,
And somebody's going
right.
to complain about it.
Yes.
I think people really underestimate the power of the optimizer in compile and go out of their way to unroll loops or put variables in weird places and try and get a little bit of optimization out and really screw up the readability of the code.
Mm-hmm.
I think you write a readable, clean code first. Try it. If it's too slow, then you try to optimize. If not, I think that's where the evil comes.
Mm-hmm. All right. Anything else? So, like I said, it's not the first or last word on the quote, but just some riffs on it and some thinking about it, and I hope that it's of interest. Thank you very much.